So my name is Jill Farrell, and I am part of the Biological Sciences Department. I'm a research master's student, and my work is funded under the Department of Agriculture, Food and the Marine, and it's part of the Marl Sites project. And today I'll specifically be talking about investigating forest roots on calcareous soils. So as we can see from this map, Ireland is very sparsely forested. The EU average of forest cover is 39%, while Ireland's forest cover is only at 11%. Increasing forestry can increase our carbon capture, it can increase biodiversity, it can increase water quality, it can increase shelter available for animals, and it provides an amenity for people. In order to increase our forest cover, one of the key areas we need to look at is marginal land. One such type of marginal land is peatland with underlying calcareous soil, sometimes known as marl, pictured here on the right-hand side. From speaking to landowners all over the country, this is definitely considered to be marginal. They more or less think it's absolutely useless for agriculture. It floods all the time, and previously it was often cut away for peat in order to burn, obviously, for our energy sources. So to identify this soil, it's identified using an acid test where you put some hydrochloric acid onto it and it effervesces or fizzes. However, current forest policy in Ireland prevents using these areas for forestry. So I've been investigating why this is, and one of the main reasons is it's believed to be a root limiting environment. I've been using a number of different methods to investigate whether or not there are roots in these soils. So that has included the core break method, which is pictured in the middle, where you simply break the core and look, is there any roots there? Root washing, where we take the soil core, we wash it, and you can once again quantify the roots through a scanning technology, and then X-raying the soil as well. So you can visibly see in situ, what are the roots like, are they of high quantity, and what is their structure? So this has been very interesting, as all of our methodologies have shown that there are in fact roots in these soils. So perhaps they are a good place to be increasing our forestry, as they're probably not a root limiting environment. However, this in itself brings around a whole host of other questions. Why are we planting forestry? Is it for carbon capture? Is it for biodiversity? Or is it for economic and commercial gain? And in particular reference to my soils, where they were mostly peatlands with this calcareous material underlying them, we have to think about the carbon capture question. Peatlands only cover 3% of the Earth's surfaces, but they store more carbon than all of the world's forests, in double. So twice as much carbon as the world's forest. So perhaps for my soils, if we're looking at carbon capture, forestry isn't the option, and maybe we should be instead re-wetting or restoring them. But these are all the questions we have to ask ourselves, and it's really important that we continue to research and to take action around forestry if we want to achieve the Department of Agriculture's vision for forestry, which is the right trees in the right places for the right reasons and with the right management. Thank you.